Today we are just going to review a little bit about finding the area of a rectangle. Now there are many different shapes, but we are going to focus just on rectangles for this lesson. So when I have a rectangle, I have this lovely shape for an example. I could measure this by looking at the length, measuring it across all the way from side to side. That is one dimension. Now I could measure it the other direction, going top to bottom. And in that case, I am now measuring in two different directions, which leads me, if I squish these together and I go, ooh, and I push and I push and I push, I'll end up with this. So here you can see how I have those same measured lines going horizontally, and I have the same measurement lines going vertically. Now each one of these are a little square. So sometimes when you talk about finding the area of something, you will hear people talk about squares. Well, that's because the shape that is made when you measure in two different directions at once, your two dimensions make nice little squares. And when you want to know how much space is covered by the surface of something, you're going to find the area in square units. So when I want to know how much space there is on this particular rectangle, I can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. That kind of took a while for me to count out. I feel like there's a faster way to do this. Now, that worked. I could totally count each individual square and I will get to the answer. However, if I notice that this is a beautiful rectangle that has all these gorgeous 90-degree corners, and every single one of these squares is exactly the same, and they form an array, I can use multiplication, because remember, multiplication is just adding in groups. So if I count across, I see that I have 10 squares. And I can count this direction and see, I have 10s going across, right? When I go this way, I can see that I have 5s. Each column has 5 going vertically. So if I do 10 taken 5 times, or even if I do 5 taken 10 times, I will end up with the exact same number as when I counted each one individually. So what is 5 times 10? Well, it is 50. This particular rectangle has an area of 50 square inches. You'll notice that my label is going to use the word square, or 50 inches squared. That word square is always going to show up. Now, not everything that I measure is going to have these beautiful squares already written in it, but as long as I can just measure one side and measure the other side, I can multiply to find the area. Here it is the same shape, and I can count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 times 10 is going to be 50 square units. Now, because multiplication can be done in any order, I could have also said 10 times 5. It will still give me 50. So we're just going to do a couple examples so that we can practice keeping track of how we find the area of a rectangle. So I'm going to grab my handy dandy trusty whiteboard here. The first example that we did together there was 5 inches times 10 inches, and I ended up counting out 50, but it wasn't just inches. I wasn't just measuring one direction. Inches, and then there's this little tiny wee 2. I can label this as 50 inches with the 2. I could also label it as 50 square inches. That would also be a thing. I can also abbreviate and say 50 IN with the little 2, or 50 square inches abbreviated. These are all accurate and they would all count as a label. What is not okay is forgetting a label altogether. If you'll notice here, I was multiplying inches times inches. I have 2 dimensions that I am multiplying together, so this is how I end up with my little exponent of 2. Now, this is the only place that 2 can go. If I put it in front, not going to mean the same thing. If I put it down here, not going to mean the same thing. If I put it over here, not going to mean the same thing. The only place my little exponent can go is right here in the upper right-hand corner of my label. Nowhere else. So let's do a couple more all together where we can use our newfound knowledge of finding the area. So let's say I have this rectangle here. And in my rectangle, I might even put a little square in each corner. That does not mean it's the size of the squares. Sometimes that can be confusing to people when they're working on a problem and they say, oh, well, what if I just draw in all the lines and then I'll count the squares? No, those little tiny corner squares are just telling me that this is a 90-degree right angle. So I know this is a rectangle. Don't let that confuse you. It is not showing me the actual size of the squares. Let's say that I am drawing a small diagram of something much larger. Maybe I'm representing a swimming pool, and I want to know how big of a cover I need to buy. So I need to know the dimensions. Let's say that my swimming pool is 20 feet long by 10 feet wide. In order to find the area, I am going to multiply these 2 numbers together. Here I had the length, or the L, and here I had the width, or the W. So one of the ways to write this is with a fancy schmancy formula. A equals length times width. And yes, I am using the lowercase cursive letters for this because these mean an unknown. Now in this case I say, hey, I know what the length is and I know what the width is. So let's plug them into my fabulous formula and figure it out. So area equals 20 feet times 10 feet. And here you will see why it's so important to put your labels down. I need to remember the correct labels for my final answer. Now I can see 20 times 10, and I know that it's really easy whenever I multiply by 10. I just move it over one more place value. Hopefully that's familiar. The area of my swimming pool that needs to be covered is 200 square feet, or feet squared. So now I know how much area needs to be covered. So let's do another one. What if I get a problem and it shows me a square I know it's a square because it has those little symbols that mean 90-degree angles in the corner. It might even have these little lines that show me each one of these lengths is congruent. Each one of these sides is the exact same length. If it only says 4, maybe this is something that is 4 centimeters. Well, how do I figure out the area? I know the area is length times width, but I only have one. Oh, but wait, it's a square. Every side is 4 centimeters long. So the length and the width just happen to match. So area equals 4 centimeters times 4 centimeters. And I will get a final answer of 4 times 4 is 16 centimeters. There's 2 of them. The area of that is going to be 16 centimeters squared. Cool? All right. Now, if you don't know what a label is, maybe it just gives you a shape, and for some unknown reason, it only gives you the numbers and you don't know what the measurement is, still always label. 12 taken 3 times, area is going to equal, 12 times 3 is 36. I don't know what the units are. Oh, I just used the word unit. Units squared, or square units. Now, what happens if I am told what the area is, but I am not told what one of the 2 lengths or what the width is? So let's say here I have, for example, one side of this is 8 inches long, and I know that the area is 32 inches squared, but I don't know what the width is. So I know that the formula again is area equals length times width. I know the area is 32 inches squared equals length 8 inches times width, but I don't know what the width is. Oh, wait, let's think about this. Oh, instead of just multiplying these together, if I divide 32 by 8, it will tell me what the width is. So 32 inches squared divided by 8 inches, 8 inches. I know that 32 divided by 8, you can work it out this way if it seems a little bit more familiar to you. I know that is going to be 4. 4 times 8 is 32, no remainder, nice and even, grand. Now there's an inch here and 2 inches on top. Oh, that will leave me with 1 left. Oh, check this out. What is the width? 4 inches. So the width equals 4 inches. Amazing how you can figure that out. So with the materials, there are a lot more things that you can do to follow up with this work. And there are also things that you can practice with paper pencil once you feel comfortable. One of the best things to do is just to work with a friend where you make up your own problems and try to see if you can solve them. So have fun finding the area, or maybe finding the length and width if you already know the area. So there you have area of rectangles.